Hello, we're going to talk about sequences today. So let's get started. Okay, so first in this chapter, we're going to look at different types of sequences and use tables and graphs to represent them. We will look for patterns of growth and use the information to develop equations that represent those patterns. By the end of the chapter, you're going to be able to distinguish between arithmetic and geometric sequences. So that's not going to all be in one lesson. I'm just kind of giving you an overview of what is coming. So we've already learned how to use a table to graph data that forms a linear pattern. Okay, so when we've had tables where we've plotted the points, and after plotting the points, we connect them, and you can see that it forms a straight line. So we're going to look at other patterns that don't necessarily form a straight line. They're going to be nonlinear. So remember, a continuous graph is connected, it's smooth, it's no gaps. If you have a sequence of separate points, then it's called a discrete graph. Okay, so we're connecting now the term discrete with sequences. So we're going to examine the bunny problem. It's a famous bunny problem. In the Book of Mice and Men by John Steinbeck, two good friends named Lenny and George dream of raising rabbits and living off the land. What if their dream came true? Suppose Lenny and George started with 2 rabbits, and during the first month, those rabbits have 2 babies. Also suppose that every month thereafter, each pair of rabbits has 2 babies. So that's really our problem here. That's the information we really need to pull out. So we have Lenny and George. They start with 2 rabbits. During the first month, those 2 rabbits have 2 babies. Also suppose that every month thereafter, each pair has 2 babies. So we got to remember that. In your digital notebook, hopefully you pulled open the slides that I've attached that are in Canvas. So you're going to want to open those slides and also watch the video, maybe side by side, or you're going to go back and forth between tabs as you answer questions and follow along. So we're going to diagram the number of rabbits over time. We're going to look at tables that show the growth over time, and we're going to learn how to write a description of the pattern of growth. Okay? All right, so in month 0, which is our starting month, how many rabbits were there? Hopefully you said 2, because that would be correct. Okay, so then after the first month, or in the first month, those 2 rabbits make some babies. How many babies do they make? Well, they make 2, but then you have to count them. So now in month 1, we have a total of 4 rabbits. Okay, so now do it again. For month 2, how many rabbits are there going to be? You start with the original 2. They have another pair of 2. And the babies from month 1 will also have a pair of 2. So you see the color coding. The red rabbits are the new rabbits for month 2. And the white and the yellow are from the starting month and from month 1. So how many rabbits are we going to have in month 3? You see that we started with 2, then we went to month 1 with 4. In month 2, we have 8. Can you figure out the pattern? Well, hopefully you can see those original bunnies are going to have 2 more. Their babies from month 1 have 2 more. The red pairs have 2 each. So now we're up to 16 rabbits. Okay? So we're going to look at the table, and you can see we have 2, 4, 8, 16 already filled in. We need to look for a pattern so we can complete this table, because drawing a bunch of rabbits or even digitally placing a bunch of rabbits in squares, it can grow quickly and take a lot more time. So if we can come up with a pattern and figure out how do we go from 2 to 4 to 8 to 16, then it'd be easier to fill in this table. Well, we know the numbers of bunnies is growing. So we're either adding bunnies or we're multiplying bunnies. I kind of think we're multiplying by bunnies. Okay, we're multiplying here. How do you go from 2 to 4, 4 to 8, 8 to 16? Well, hopefully you can see that that's a multiplier of 2. Okay, now if you know your multiplier, then you can continue the table without having to draw bunnies or digitally add bunnies. You can just keep multiplying by 2. All right, so go ahead and fill in your table, and let's see where you get at month 12. Well, by month 12, you should have gotten to 8,192 bunnies. So I know that if your month 12 is correct, then the previous months have to be correct. Because if you make one mistake along the way, then you won't have that right answer at the end. Okay? Alrighty, so how do we write about this? Okay, so there's several ways to describe this bunny problem. After each month, the number of bunnies is 2 times the previous month. That's one way to explain it. After each month, the number of bunnies has doubled. I like the word doubled because it tells us something, right? It would be correct to say that the number of bunnies is increasing each month. However, it is not clear by how much. We would need to identify the multiplier that generates the terms of the sequence. In this case, the multiplier is 2. So when we say things are doubling, we know that means the multiplier is 2. And it just sounds fancier than saying times by 2, right? What about if it tripled? That would be a multiplier of 3. Okay, so let's look at the next situation. It says Lenny and George want to raise as many rabbits as possible, so they have a few options to consider. They could start with a larger number of rabbits, or they could raise a breed of rabbits that reproduces faster. So which one is going to yield the most amount of rabbits after 1 year? Well, let's see. We have 3 more cases. We started with case 1 where each pair had a pair, right? Or case 2, we're going to start with 10 rabbits and each pair has 2 babies per month. So you're starting with more, but they're still having the same amount per pair. Case 3 is you're starting with 2 rabbits, the same amount, but now each pair is having 4 babies per month. We start with, in case 4, we start with 2 rabbits, but each pair has 6 babies per month. So which of these cases, starting with 10, having 2 more per month, or starting with 2, having 4 per month, starting with 2, having 6 per month, which one do you think is going to yield the most rabbits after 1 year? Well, let's find out, okay? So in case 2, if you start with 10, remember, 10 bunnies each are not having a pair. Each pair is having a pair. So how many pairs, I know it's confusing, isn't it? How many pairs are in 10? Okay, hopefully you said 5. So that means I have 5 pairs. Well, let me make 5 little circles here. And I'm going to put the number 2 in each one because that means that these are a pair. And they're going to have 2 babies. My pen's having a delayed reaction. So this isn't the prettiest diagram, but this is what you should be doing maybe on a separate sheet of paper, a graphic organizer, and to kind of figure out, maybe at least diagram the first few months, because it does get tedious. It takes up a lot of space if you go beyond that. So each pair of bunnies had 2. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus my pairs 12, 14, 16, 18, 20. Okay. Now I don't want to draw the next month. So let's go month 1 had 20. Think about it. How many pairs are in 20? Well, there's 10 pairs having 2 babies each. That makes 20 pairs, not 20 total, but 20 pairs gives us 40 bunnies. Okay, so once you've got a couple months in there, you should be able to look for a pattern, a multiplier, because bunnies multiply. 10 goes to 20, 20 goes to 40. It seems to be that we're doubling again. Okay, so we're doubling again here. So if we continue the pattern of doubling, at month 3 we have 80. At month 4 we have 160. And month 5 we have 320. So you're going to have to continue this pattern on your own to get to month 12. So I'm just getting you started. You need to get to month 12 so you can answer this question. All right, so let's look at the next case. The next case says start with 2, and then they're each going to have, each pair is going to have 4 bunnies each. So in month 1, if I add 4 bunnies to the first pair, then that's a total of 6, right? 2 plus 4 is 6. So it takes 2 to make the babies. So now how many pairs, that's the key here, how many pairs are in 6? Well, how about 3 pairs? So I'm going to put 2, 2, and 2. And each of those pairs has 4. So we're going to go 1, 2, 3, 4. 1, 2, 3, 4. There's got to be a better way, right? So I've got 4. I'm just going to count each stick as one baby because it's going to take too long for me to draw these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we got to go 14, 16, 18, counting those pairs. So after month 2, there's 18 bunnies. Well, I think we're already past drawing more of these. So how do I go from 2 to 6, from 6 to 18? What could our multiplier be? 2 times what is 6? Hopefully you said 2 times 3 is 6. 6 times what is 18? Hopefully you know that it's still times by 3. So continue that pattern. In month 3, you should have 54, right? And then in month 4, you should have 162. And in month 5, you should have 486. Now you're going to have to continue this pattern of multiplying by 3 on your own so that you can come up with the correct answer for which case yields the most after a year. All right, so I'm going to get you started on case 4, and then I'm going to have you guys finish it. So case 4 says what? Start with 2. Each pair has 6. So in this case, in month 1, if this first 2, our starting pair, has 6 babies, I add 6 to 2 and I get 8, right? Now, month 2, 3, 4, and 5, I want you to figure out, but I'm going to give you a little shortcut. Just figure out 2 times what is 8. Since in this particular problem, be very clear, we know it's going to be a multiplier. So 2 times what is 8? Okay, hopefully you know that 2 times 4 is 8. So instead of drawing, I'm going to keep multiplying by 4. It's 32. And then you're going to multiply 32 by 4. And you're going to get 128. Okay. All right, so you continue the table so that we can move on and compare. We're going to look at the graphs of these things, okay? So what you're going to do on your slide is you're going to click on the links, case 2, case 3, case 4, those are links, and you're going to create a graph in Desmos. Okay, so let's start the first one. And I've got your table started. So when you click on the link, it'll open up your own. We're starting with the one that starts with 10 rabbits, and then it increased to 20, and then 40. And we're going to keep going, and we're going to fill in actually the 6th month. We didn't go to the 6th month on the other screen. 640 here. I want to show you how to work with Desmos. Well, we've done a little bit of work with Desmos, but as you can see, you can only see one point. So you're going to have to click and hold and drag until you can see. And I can either, I can zoom in or zoom out. Okay, so if I zoom out, I'll see more of the points. If you keep zooming out, you might think that this is a straight line, but it's not quite. You see, So I'm going to zoom out more so I can tell that it is not a straight line. Now, one way to help yourself is you go back over here. Just didn't mean to do that. Go back over to your table, click and hold the circle next to the Y1, and then click this lines. Okay, so it's going to connect them. So again, it's starting to look a little bit like a curve. I know it's tough, but if you go to this where it starts here, where it starts, it's kind of curving out. So what I want you to do is I want you to take a screenshot of that, and you can see I already have it here. I'm going to copy that and bring it back to the slides, and I'm going to place it here. Okay, so you're going to have to do some cropping or sizing to get it to fit in there. Okay, so that's my case 2. So you guys, I want you to do the same thing for case 3 and for case 4. You're going to put in those table of values, create the graph, and then copy and paste it and put it into the slide. Okay, so hopefully your graphs match mine. I mean, it depends on where you cropped it because some of mine go to 40. This case 3, it only goes to the past 25. So you're not going to see the entire graph, and I don't expect you to, because if you try to do that, it will just look like a straight line. So they pretty much follow the same general shape, general pattern. Okay, and that's what I wanted you guys to notice. Now, how do we describe the graph? We say that this is an exponential function. Okay, so if it has this curve, this little curve, and it kind of shoots up into, like, pretty fast and almost linear, then you want to say that it's an exponential function. Okay, so let's look at the y values of the original bunny problem. Now I'm talking about in the table, you see 2, 4, 8, 16, 32, 64, 128, so on and so forth. We call this sequence geometric because it is generated by multiplying each term by 2 to get to the next term. So it's not that it's being multiplied by 2 that makes it geometric. It's the fact that it's being multiplied. Each term is being multiplied by something to create the next term. That's what makes it geometric, and that's what makes the function exponential. So the sequence is geometric, the function or the graph is exponential. We're going to examine them more in the next lesson. We're going to look at geometric sequences, and we're going to be able to come up with the equation that creates the graph. All right, I'll see you guys next time.